So eventually, using Excel, we'll come up with that regression output. Again, in the course material, I'll demonstrate to you how to obtain this regression output. Yes, there's a lot of numbers here, but particularly we just want to focus in these two there. The intercept coefficient, which is 21.68 here, and the slope coefficient, which is 5.46. From the regression output, we can obtain the intercept and the slope coefficient. The intercept coefficient, beta 0 hat, is 21.6806. The slope coefficient, 5.4622. Going back here, there is the intercept coefficient. There is the slope coefficient. Now we can present the estimated regression equation as follows. Y hat is equal to beta 0 hat. Now we've got the value of beta 0 hat, 21.6806, plus beta 1 hat is 5.4622x. Okay? Importantly, now we are going to do the interpretations. Let's interpret the beta 0 hat, the intercept. With that value, we computed from Excel to be equal to 21.6806. The intercept is the estimated value of the y when x is 0. So again, essentially the intercept is just the estimated value of the y when your x is equal to 0. So in the context of our example, sales and advertising, the interpretation will be as follows. When there is no x, when there is no expenditure on advertising, remember the x is advertising expenditure, the shop can expect to obtain $21,681 worth of sales per month on average. Okay. When x is 0, y hat is 21.6806, but we have to make it into thousands. Remember, the unit of measurements of sales is in thousands. So again, we can say this. When there is no expenditure on advertising, the shop can expect to get $21,681 worth of sales per month on average. Interpretation of the slope. Beta 1 hat slope is equal to 5.4622. Essentially, the slope means this. By how much the y will change when x increases by 1 unit. Okay? Hence, in the context of our example, the interpretation will be as follows. When advertising expenditure per month increase by 1, but remember 1 here means $1,000 because the unit of measurements on advertising expenditure is in thousands of dollars. Okay? When advertising expenditure per month increases by $1,000, the shop can expect to increase its monthly sales revenue by 5.462 in thousands, $5,462 on average. So let me read that one more time. The interpretation of the slope in the context of our example would be this. When advertising expenditure per month increased by $1,000, the shop can expect to increase its monthly revenue by $5,462 on average. Forecasting. Using the obtained regression linear equation, we can do a basic forecast. That is to say, predicting or forecasting the value of y for a given value of x. Recall the obtained regression equation in our sales advertising example. Y hat is 21.6806 plus 5.4622x. Suppose the manager of the store wishes to know how much sales he can make per month if he spends $2,500 on advertising. So simply substitute 2.5 in thousands of dollars as the value of x to obtain the estimated value of y. So very simply here, guys, you got your regression equation. If x is 2.5, substitute 2.5 as the value of your x, then you should be able to compute y hat to be 35.3361. Hence, we can infer that if $2,500 is spent on advertising per month, the shop can expect to make a monthly sales revenue of $35.3361 in thousands, yes, $35,336 on average. Quite simple, guys. This is what we call doing a basic forecast for the value of y for a given value of x. You should have now been able to obtain and interpret the intercept and the slope coefficient from an estimated regression equation for use in business decision making, and being able to apply a relevant computing application, that is to use your Excel to estimate the regression equation. Make sure you watch the video that I've put in the course materials on how to use Excel to run regression. And in addition to that, we've also done a basic forecast, a simple forecast using our regression equation to forecast the value of y for a given value of x. Thank you. Bye for now.